Hello everyone, I'm Shweta. My friend Sindhu. We are presenting this topic explainability and transparency in AI decision making. These are the summary in these presentations. And coming to this topic, we choose under the three academic articles here. For introductions in this topic, the AI impact on decisions, AI shaping diverse industry through the automation and data-driven insights. In AI advancement revolution, decision making for faster and more accurate. For complex system, the both challenging in transparency and users technologies. For including the ethical dimensions of this topic, we have accountability, transparency in AI decisions. We include the building trust challenges of transparency. The challenge and transparency make trust becomes the pivotal role in effective collaborations with AI, transparency and agency decisions. And coming to the next slide, it is the architecture of explainable artificial intelligence for AI and ML engineer. We have some data collections and data pre-processes. We have modeling the data and evaluation it. We have you model the training. We have some predictions on humans and evaluation need. We have using the black box model to use in this pictures an explainable artificial intelligence. And coming to the next slide, we have problem statement. The problem statement in this, what are the problems in this paper? We have the importance of explainability in the world, implications, concerns and bias in AI. We need to understand the AI statement for trust. Lack of transparency for explainability cannot be overstated. Without the explainability may lead to the hindering real-world implication of AI decision or vast impacts in scenario region from finance of healthcare. We have lack of explainability, transparency in usual unfold standard. For AI bias training data, we have ideas unfair outcomes. We have concept of explainability. We have what are the concept in this paper? The definition explained in AI, human AI collaborations, practical applications. In Unravel, the clarity in decision making, making AI process interpretable, stakeholder involved. The clarity is not just a technical necessity; it is a concentrate for the effective collaboration between humans and AI system. By ensuring the process, we have collaborating, participated decision making, that enhances the overall decision landscape. The concept of explainability find practical application across diverse domains as healthcare, finance, legal systems in healthcare. The legal system requirements transparency in we have more decision making, legal, regulatory transparency requirements. And coming to the next slide, we have transparency in AI. Transparency in AI definition of transparency, mitigation bias, user empowerment, ethical alignment. The transparency in AI refers to the decision making process, the open and understand. In address bias, promoting fairness. In transparency, it control and AI decisions. In ethical principle, it respectful to use the AI decision relationship decision made AI systems. Moreover, the transparent they align seamlessly with ethical principles. And move to the next slide. This is the article 1. We choosing the under this topic the leveraging explainable AI models towards identifying classification issue on IDS data sets. These are the AI growth in 2012 significant advancement due to the technology improvement. They based support system tool enhance the decision making capabilities. The paper proposal involves three crucial pillars: transparency, explicability, interpretability. The extensions insight into the AI system emphasizes the openness and clarity in AI decision, making AI decision easily explainable. Focus on assigning accountability for decision making that related to the attribute and responsibility. And coming to the next slide in AI, the human AI based tool interaction, how human and AI interact with each other. This is the picture explains how human and AI interact in each other. The agent and the system agree if what are the actions is put in the pictures. That's all.
Okay, coming to the next slide, we are going to summarize the article 2, Explainable AI via Linguistic Summarization of Black Box Computer Vision Model. Focus on challenges in anomaly-based instruction detection system, IDS, include false alarm and dataset limitation. Propose to leverage explainable artificial intelligence XAI methods, specifically SHAP, for improved explainability. experimentation on the widely used NSL-KDD dataset using a random forest model, identification of severe imbalance in the number of records per attack type in the NSDL-KDD dataset, proposal to address dataset imbalances through target training of a new RF on attack types. In this slide, we are going to compare the SHAP-B swarm for class DOS and SHAP-B swarm plot for class prop. So here, the SHAP summary and GIN impurities produces similarity result with matching most important feature and small difference in the ranking. Comparing the SHAP plot for the prop with the domain knowledge, it becomes evident that the ranking of the importance of the feature is highly dependent on some attack types. Coming to the third one and the fourth figure, it represents the plotting between the Neptune and the Saturn. This will explain the explanation formally belong to the attack class prop. Only the sharp plot for Saturn will be giving the output. On the next slide, it is an Article 3, Building Confidence and Acceptance of AI-based decision support system through explainable and liable AI. Introducing of a hierarchical approach for generating and ranking linguistic summaries of a computer visual model. Validating the proposing approach against traditional graphical explanation gives more attention. Overcome challenging of complex models will giving through the structural interpretation. User-tailored summaries contributes to a more personalized understanding of a model performance and decision making. Simultaneously, imaginary addressing the different difficulty of obtaining diverse real-time world data for evaluating computer visual models. Okay, in this article, we are going to find two examples, which is one is an qualifier architecture and explainable AI process. So, in this evaluating process, the explainable AI process for generating and using linguistic summaries, first a detector is trained, then evaluating. Next, an interactive network of possible statement describing the model is constructed and filtered based on user criteria. And the next one will explain the architecture. This qualifier architecture will say about the many low confidence detection are at the far Stanford distance and low elevation angles, which will give the two qualifiers and the one summarizer. In this next one, evolution of method. This evolution of methods will give us two kind of articles. Give us three kind of articles. One is the first article will give us a sharp for NIDS debugging, emphasizes on dataset balances. The second article will give an hierarchical linguistic summarization, which gives the measures like truth, focus, complexity, and relevancy. Article 3 will give the challenging in model interpretability, aligning interpretability. On the early methods in the 2010, rule-based system, handcrafted features and simple decision trees takes place. In the transition period of 2010, featuring importance matrices, local interpretable model agnostic explanation will take place and sharply additive explanation are taken place. Recent approaches after the post of 2010, neural network interpretability, attention mechanism and layer-wise relevance propagation has taken place. In this proposed method, we see the commonalities comparing to the three articles. Both articles focus on the importance of explainable AI methods, addresses challenges relatable to complex models in instrumentation detection and computer vision. Introducing or use matrices to measure interpretability and model performance. Coming to the trend and emerging technique, highlighting the use of SHAP, which is said to be a sharply additive explanation method in the first article for feature analysis and model debugging. Emphasize the use of linguistic summarizers in the second article to provide human interpretability description of computer vision model. Coming to the last conclusion, it addresses the false alarm in NIDS leveraging XAI models and then enhancing understanding of computer vision model through linguistic summarizers. In the article paper we have go through. Simultaneously, the data for systematic evaluation of computer vision model also takes place. The crucial role of transparency in AI decision making will make an emerge interpreted in the article. Evolving landscape plays a regularly emphasis on AI transparency. We have completed our presentation. If you have any questions, you can ask. Thank you.